Hello friends, welcome to Learner's Planet. Friends, this is our first problem solving session for algebra. In the previous two sessions, I have discussed various concepts related to algebraic identities, expressions. I have discussed linear, quadratic and various other types of equations, discussed nature of roots as well. We discussed powers and exponents also. So in this session, we'll be taking some basic problems based on algebra. Okay, so let's begin this session, and you must revise the previous sessions, that means the basic concepts of algebra, before you come for this session. So you feel comfortable while we solve the problems, and do have your paper and pen with you. So let's begin. Now a simple problem, a factor of x cube minus 1. Now this is what? A cube minus b cube format, right? So it's x cube minus 1 cube, so it's x minus 1 x square plus x plus 1, right? You should be able to recap this expansion, right? Here y is 1. So x cube minus 1 will be having factors as x minus 1 and x square plus x plus 1, both of them. So either A or B, right? Now friends, we have this problem, quotient, remainder and divisor is given. We have to find out the dividend. Now in general division, as you already know, dividend is equal to quotient into divisor plus remainder, right? I just put up a quick example. Suppose it is 13 divided by 5. So 13 will be equal to 5 into 2, that's divisor into quotient plus remainder, right? The same thing will be applied over here. So we have to find out dividend, that means quotient into divisor plus remainder, right? Now that's 3x square minus 2x plus 1 into x plus 2 plus 2x minus 5, right? Now here the constant term will be 2 and here it is minus 5. So finally constant term will be minus 3. So these two are eliminated, okay? Now in the remaining cases, coefficient of x is negative and positive, so we just can calculate the coefficient of x. No need to make the entire calculation. So in this case, coefficient of x is this 2 into minus 2x minus 4x, then this is plus x and this is 2x, okay? In all, the coefficient of x will be 2 plus 1 3, that's minus 4x plus 3x, that is minus x, right? So coefficient of x is minus 1, that's there in this case, okay? So no need to calculate further. So this way you can save some of your time, right? I hope you are clear. Now this one, x minus 2 is factor of this and this, we have to find out the value of a plus b, right? So if x minus 2 is factor of this, then that means if you put x is equal to 2 in this equation, the value of that will be 0, right? So I put 2 instead of x, so 4 plus 2a minus 6 is equal to 0. That means 2a is equal to 2a is equal to 1. Similarly, if we put x is equal to 2 in this equation, the value of it should be 0, right? So 2 2's are 4 minus 9 into 2 18 plus b is equal to 0. So b is equal to 14. So a plus b will be 14 plus 1 15, okay? Now in this problem, this multiplication is given and we have to find out the coefficient of x, right? So coefficient of x will be obtained from 7 into 3x, 21x and 5x minus 4. So that's minus 20x, right? So 21 minus 20, that's x. So in all, minus ax is equal to 21x minus 20x, that is x. That means a is equal to minus 1, right? Or precisely coefficient of x over here it is minus a and coefficient of x here it's 1, that means minus a is 1 or a is minus 1, right? Now this one, the value of this when x is 1 and y is minus 1, pretty simple. It's 25 plus 16 and this will be x into y will be minus 1, so it's minus 40. 25 plus 16 41 minus 40 is 1, right? Here it's a minus b whole square is expanded as this, and the middle term is missing, so that we have to find out. So a minus b whole square is what? I write it over here. A minus b whole square is a square minus 2ab plus b square. Now a square is given, b square is given, this middle term we have to find out. So that's actually this into this, right? And it will be in negative. Okay, so 3 and 3 is cancelled, 4 and 4 is cancelled, so that's minus 2xy, right? So what will come over here? Minus 2xy. Okay, do not make positive negative mistake over here. Already positive sign is given, but your answer will be negative, so you need to put minus sign. Okay, because this is a minus b whole square, so be careful about it. Okay, now in this case, now friends, whenever you see this sort of complicated calculation, obviously some algebraic identity is there, is involved there, right? This is a square minus b square. So a square minus b square can be factorized as a minus b into a plus b, right? So a minus b is what? 7.83 minus 1.17, right? So that's 6.66 into 7.83 plus 1.17, so that's 9, right, by 6.66. So finally your answer is 9. Simply you can solve it if you know the algebraic identity, right? Now this one, x minus 1 upon x is given. You need to find x square plus 1 upon x square. Very simple. Square this. So what you'll be getting? X square plus 1 upon x square minus 2 x into 1 upon x. So that will be 2 only, because x and 1 upon x will be cancelled to produce 1, and that's 6. So x square plus 1 upon x square is what? 6 plus 2, 8. Right? Similarly, in this case, x square plus 1 upon x square is given. We need to find out x plus 1 upon x. So what I do is I subtract, or add 2 this side, because I want x plus 1 upon x, and this side also I add 2. So it's 81. Now this is what? X plus 1 upon x whole square. That's 9 square. That means x plus 1 upon x is 9, right? From this to this, you must be knowing this is a plus b whole square. That's a square plus b square plus 2ab. When you do 2ab, x and x will be cancelled to produce 2, right? So this expression can be written as like this. Okay. Now this problem, 3x minus 7y is given as 10, and x minus xy is minus 1. We have to find out the value of this. Now, instead of making a quadratic equation, what you can do is simply square this, because 3x whole square is 9x square, and 7y whole square is 49y square. That means this term is squared, right? So 3x minus 7y whole square is 100. So this is a minus b whole square, so that is a square plus b square minus 2ab, that is 100. Now you want this, so I put up the value of xy, that's minus 1. So this is minus 2 into 3 into minus 1, so it's 2 into 3, that's 100, right? So 9x square plus 49y square will be 100 minus 6, 94. I'm sorry, I missed 7 over here. So it's 7 3s are 21, 2s are 42. So 100 minus 42, 58. Okay. Just put up xy as minus 1. So it will be positive 2 into 3 into 7, right? So this value will be 100 minus this expression. So 100 minus 42. So that's 58. Okay. Now this problem. Further, this is an algebraic identity. See, if you are knowing the algebraic identity, do not write that in your examination paper, right? In your rough sheet or whatever. Do not waste your time. Straight you can solve. A plus b plus c whole square will be a square plus b square plus c square plus 2ab plus bc plus ca, right? That means 100 is equal to 36 plus 2 times this term, suppose it is x, right? So you have to find out x, AB plus BC plus CA. So that will be 100 minus 36, 64 by 2, 32, right? So it's as simple as that, right? You don't have to write the entire expansion over here. Okay, for your convenience I am writing it for you, but you don't have to write. You should be knowing this, right? So a plus b plus c whole square is a square plus b square plus c square plus 2 ab plus bc plus ca. Now you want this, put up a plus b plus c, that's 10, so it's 100 is equal to this 36 is equal to 2 times this, the same thing I have written over here. Okay, so this calculation or this expansion should be there in your mind. Okay, no need to waste your time in writing this. I hope you are getting me. Now in this case, x minus y is given as 4 and xy is 21, x cube minus y cube. See, there are two methods. One is lengthy and one is very fast. If you can observe it very clearly, x and y, the difference is 4, product is 21. So x must be 7 and y must be 3. So difference is 4 and product is 21, right? Now put up very quickly, 7 cube 343, y cube, that's 27. So 343 minus 27, 316 is your answer, right? This is the shortest way. After that, if you're not clear about, if you're not able to recall or not able to conclude this, what you can do is x cube minus y cube is actually, that will be but lengthy method, but I explain you. X minus y, x square plus y square plus xy, right? So that's x minus y. Further, we don't know the value of x square plus y square, so I'll be writing x minus y whole square, and in expansion of this I'll be getting minus 2xy, but we don't have minus 2xy over here, so I'll add 2xy. So this minus 2xy and this 2xy will be cancelled, right? So this can be written as this. Okay, now you know x minus y, so that's 4, x minus y whole square, so that's 16, plus 2xy plus xy, that's 3xy, that's 63. Okay, so precisely 63 plus 16, so that's 79 into 4. Okay, but this will be a bit lengthy or time consuming. This is like shortest. So I hope you are getting me. Now this problem, a plus b plus c is 9, ab plus bc plus c is this, a cube plus b cube plus c cube minus 3abc we want, right? Now I have discussed the formula for a cube plus b cube plus c cube minus 3abc, that is a plus b plus c, a square plus b square plus c square minus ab minus bc minus ac, right? Now in this case you don't have value of a square plus b square plus c square, right? So what we can do, a plus b plus c whole square is a square plus b square plus c square minus, plus 2 ab plus bc plus ac, right? So from this I'll be calculating this, and from after calculating this I'll putting the same over here, right? So this is actually a cube plus b cube plus c cube minus 3abc, this entire expression that I have already discussed, right? Now a plus b plus c whole square, that's 81. I want this, so plus 2, AB plus BC plus AC is 26, so 26 into 2, 52, right? So A square plus B square plus C square is 81 minus 52. So that's 29, right? I put 29 minus AB plus BC plus AC, that's 26. A plus B plus C is 9. So 29 minus 26, 3, 9 into 3, 27. Okay, isn't it very easy? You just be knowing, you should be knowing algebraic identities, that's it, nothing else. Now this problem, if x cube plus y cube plus z cube is 3xyz, then relation between x, y and z. I have discussed this identity, x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. And I have already told you that this identity is going to be really important, right? Now, in this case, if x plus y plus z is 0, then this entire right hand side will be 0. So x cube plus y cube plus z cube will be 3xyz, right? So x plus y plus z is 0, or we can see that x is equal to y is equal to z. If x is equal to y is equal to z, then also this right hand side will be 0, because in that case x, y, z, this expression will be minus x square minus y square minus z square. So the entire, all the terms will be cancelled out. So further it will be 0, right? So either x plus y plus z is 0 or x is equal to y is equal to z. This is the correct choice. So in both the cases, x cube plus y cube plus z cube minus 3xyz will be 0, or x cube plus y cube plus z cube will be equal to 3xyz. Okay, an important concept, friends, just keep that in your mind. Now this question, a lies between 0 to 1, then value of a plus 1 upon a. Friends, a is lying between 0 to 1. That means a is necessarily a positive quantity, obviously, because it is greater than 0. So whenever this is a positive quantity, a number and its reciprocal sum is greater than 2, right? A is a number, it is its reciprocal, so it's greater than equal to 2, right? Provided a is positive. Okay, so it's always greater than 2. We cannot set the maximum limit greater than 4 or less than 4. Greater than 4, it is not necessary. If a is say 2, then it will not be greater than 4, right? If a is say 3 by 2, then it will not be greater than 4, but it will always be greater than 2. You can take any positive value of a, not necessarily between 0 to 1. You can take any value, right? It will always be greater than 2 if a is positive. Okay, now see this. Once again, as I have already told you, if you see this sort of typical calculation, just try to recall algebraic identities. Here it's a square minus b square format. So it will be a minus b into a plus b, right? If I do a plus b, it will be 67.542 plus 32.458. It will be clearly giving you 100, right? Now a minus b, 67 minus 32 approx, it will be 35 point something something, and in the denominator 75 minus 40, that's also approx 35. Bright chances are there this calculation and this calculation is same. 8 minus 4, 4, 5, yeah, it's totally same. So these are cancelled, you're left with 100. That's it. Okay, this data may confuse you because it's not exactly a minus b, but the answer of a minus b in the numerator and denominator is the same, right? So this way you can like cancel it. Finally, this number is same. Okay, so finally you are left with 100. Now this one, a square plus b square plus c square minus 3abc. This is a square plus b square plus c square minus AB minus BC minus AC. I'm sorry friends, it's mistake, it's cube. Okay, so it's a cube plus b cube plus c cube minus 3abc, right? So have a quick recap. A plus b plus c, a square plus b square plus c square minus ab minus bc minus ac. This is the expansion, but you don't have to write in your examination. That you must be knowing, right? So a cube plus b cube plus c cube minus 3abc is this. So if this expression is divided by this, you'll be getting a plus b plus c. That's it, right? So if you know this identity, this problem is the matter of seconds only, right? Now what is a plus b plus c? 0.42 plus 0.25 plus 0.33, that's 1. As simple as that. It's a matter of seconds. Even you don't have to write this identity if you know that in your mind. Okay, a cube plus b cube plus c cube minus 3abc by a square plus b square plus c square minus ab bc ac. That will be just a plus b plus c. That's 1. As simple as that. Okay. Now in this case, it is further a cube minus b cube. So a cube minus b cube is what? A minus b. a square plus ab plus b square. So that is in the denominator. You can say 31 square 961, 21 square 441, and 31 into 21 must be 651. So, and answers you can see very simple answers are there. So no approximation, nothing is required. This a square plus ab plus b square will be cancelled from the denominator. So finally you are left with a minus b. So 0.31 minus 0.21. Finally this is okay. So that's 0.1. Okay. See this one. 2x plus y is 5, 4x plus 2y. Pretty simple. It's double of that. So it must be 10. Matter of 2 seconds. Now this one. It's 55 cube minus 75 cube plus 20 cube. As I've already told you, if a cube plus b cube plus c cube minus 3abc, it will be 0 if a plus b plus c is 0. Here a is 55. B is minus 75 and C is 20. That means A plus B plus C is 0. That means A cube plus B cube plus C cube will be 3A. This is A. B will be minus 75. Be careful about it, and this is 20. So finally your answer will be negative. For that you need to be careful. Okay. So this is not the answer. This is not the answer. Only this could be your answer. Since you have none of these also there, so to certain extent you need to check. 55 is multiple of 11. Let's see this number is multiple of 11 or not. So 4 and 5, 9, 7 into 9. So pretty simple. This number is multiple of 11. Then this number is multiple of 3 as well. So must be the correct choice. Okay. Similarly, a cube plus b cube plus c cube minus 3abc. By this, as we have just discussed in the previous question, that will be just a plus b plus c. Okay. So I'm sure you'll be getting a grip on this identity, that is a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into this expression. Okay, so that's an important identity, time and again I'm telling, but good number of problems we have solved on based on this identity. So I'm sure now it's like setting in your mind now. Okay, now we have this. We have to find out the factors of this expression. If you clearly observe it, this, so that's actually x plus 1 upon x whole square, right? That will be x square plus 1 upon x square plus 2 into x into 1 upon x. So x into 1 upon x will produce 1. So only 2 will be left. Minus, if I take 2 common, I'll be getting x plus 1 upon x. So from these two terms, we can take x plus 1 upon x as common. That means x plus 1 upon x is definitely a factor. We have nothing to do what is left after taking x plus 1 upon x as common, because we have that in our option, and since there is none of this, you can blindly mark x plus 1 upon x because that's perfectly a factor. Okay. Now this problem, here this expression is m square minus n square, then m is equal to. Now friends, you just can observe this, the x square plus 5, and here also we have x square plus 5. So precisely this expression is x square plus 5 plus 3x and x square plus 5 minus 3x. Right? So this is a plus b format, a minus b format. That means it is x square plus 5 whole square minus 3x whole square. So that's 9x square. Now this is m square minus m square. So m will be what? X square plus 5. Okay. Now factorization of this expression seems to be tedious one. Again, try to observe a cube plus b cube plus c cube format, or do not get confused between variables. X cube plus y cube plus z cube will be 3xyz if x plus y plus z is 0. Now here, if you suppose this is x, this is y, and this is z. So x plus y plus z will be what? A minus b plus b minus c plus c minus a. So that will be 0. That means x plus y plus z is 0. That means x cube plus y cube plus z cube will be what? 3xyz. So 3 a minus b, b minus c, c minus a. As simple as that. Again, the usage of that particular important identity which I am telling you time and again. Okay. Otherwise, it's pretty difficult to solve. You will like spending 10 to 15 minutes, still you will not be able to find out the correct answer. Okay. So I hope you are getting me. Now this one, again, on an algebraic identity of a plus b plus c whole square, we don't have to write the identity. A plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus bc plus ca, right? So this is suppose x. So x square, that means a plus b plus c whole square is equal to a square plus b square plus c square plus 2ab plus bc plus ca. So here it is 2 into 10, 20. So x square is what? 44 plus 20 is 64. That means a plus b plus c will be plus minus 8. As simple as that. Okay. Now this one. Here x minus 1 upon x is given and we have to find out the value of this. Now this is a cube minus b cube format. So that will be equal to a minus b a square plus b square plus ab. That is this into this. So that's 1, right? A minus b, a square plus b square plus ab. Now you know the value of this. This is actually this. You know the value of this, but you don't know the value of x square plus 1 upon x square. So that can be calculated from here. See, x minus 1 upon x is 6. So if you square both the sides, what you will be getting? X square plus 1 upon x square minus 2 is equal to 36. Okay. I squared this from both the sides. X square plus 1 upon x square plus 2, minus 2x into 1 upon x. So that will be 2 and that is 36. So x square plus 1 upon x square is 38. Right. So this is 38 plus 1, 39, and x minus 1 upon x is 6. So precisely your answer is 6 into 39. So that is 240 minus 6, or that's 234. Okay. So friends, in the next session we'll be taking more problems based on algebraic identities and concepts, and we'll be taking the problems on powers and exponents as well. So I'll see you in the next session once again. Bye bye.